as a researcher. But this isn't directly related to e-learning. Obviously it's applicable, but today I'm going to talk about a project which finished, or is going to finish at the end of this year, 2011. It belongs to the Spanish Institute for the Normalization of Telecommunications, sorry, the European Institute for the Normalization of Telecommunications. And you can see the name of the people behind this in the presentation. We are people who have worked at analyzing the problems related to accessibility when we're talking about man-machine telecommunications and interaction, and how we can solve these problems. I would like to briefly introduce then and explain what ETSI is. The European Institute for the Normalization of Telecommunications, together with THEN and THENELEC, are one of the, or are three of the official standards organizations in Europe. ETSI is recognized because it generated the GSM standard. And this enables us to travel all around Europe with our mobile phone without having to change. We can use our SIM card in other terminals and it works. We can send and receive data. And this standard, the GSM standard, in itself has meant that the ETSI, the European Institute, is very representative, above all, of the industry. Not so much users or public administration. In ETSI, what we have are manufacturers and operators of telecommunications. Another thing I wanted to mention is that ETSI takes into account the human factor, and it works not just to improve or work on accessibility, but also looking at ethics and privacy. And ETSI, in comparison with other organizations in standards, well, all of the ETSI standards can be downloaded for free for personal use from internet. www.etsi.org. That's the website. You just register by just giving them your email. They don't usually send spam or anything like that. And you can download the standards. The name of the project that we're going to present today is STF377. And, well, the idea that arose was that new interaction technologies should represent many advantages for users, but these new technologies do not always take into account the needs of all users. In the best case scenario, sometime after a new technology appears, solutions are offered in order for this technology to be accessible. I'm going to give you an example. iPhones. This object of desire, which is so successful in society today. The first versions were completely inaccessible for disabled people, above all for blind people. In the third version of iPhone, Apple included as a standard element in iPhones, iPads, etc., a new technique which is voiceover, which allows, well, even though somebody is visually impaired, they can use the device. They have special screen reader, and the user can use this touch screen to get an audio response from the system. And this meant that the product was accessible. That's not just the case of iPhones, but also there are other mobiles that weren't accessible at the start, and some operating systems, some mobiles, allow us to have screen readers that also develop accessibility for blind people, as in the case of the Code Factory, who were here today with us at this conference. So all of this came after the first versions of the mobile phones, which had many issues, many problems with regarding accessibility for disabled people. And this is the same story as always. If we remember the command line interfaces, and nobody practically remembers this anymore, and people maybe who program Linux are very systems experts, they're still used to programming with command lines. But we had Optacon, this system. This could read character by character, word by word, what a screen displayed. When the user interface design was changed, and now we came to the concept of WIM, windows, icons, menus, and cursor, then Optacom just stopped working. And the screen readers had to be developed in order to recognize the information that a graphic environment based on 2 dimensions. In the past it was linear, it was just sequential. They had to change in order to manage the information that came in windows with different menus, and each menu offering different options. Now we're very happy with, well, sometimes at least, we're happy with the touchscreens, with the accessibility of some operating systems, and we're starting to talk about new forms of interaction, such as virtual reality. And I could have a system according to which, or by which, I could have information printed on my glasses. I could read information about where I find myself via information which is superimposed. And this new step, no doubt, will represent a new challenge for accessibility for people with disabilities. We have another example here. At the top, we have a phone keypad, similar to the average phone that most of us have. This is a phone where we have a mechanical keypad. And at the bottom, we can see, well, this is magic. The slide seems to work by itself. There must be some telepathy going on here. Without meaning to, I'm changing the slide. But now we can see at the bottom an interface based on a touch-sensitive phone. Basically has the same function as the numerical touch, the physical mechanical keypads that we had at the top. If we rubbed off the characters that appear on a phone keypad, if we thereby simulated how a blind person would be interacting with the phone, well, imagine that on number 5 we have something embossed, and if there is some kind of standard for the positions of the keypad, 1 at the top left, 9 at the bottom right, then a blind person can use the keypad, and the call button, if it's on the left and hanging up is on the right, then a blind person could use a telephone, a mobile phone, without any problem. But if we think of somebody, a blind person, using an iPhone, well, they wouldn't be able to access to any kind of information, in the original version at least, which have a touchscreen. So, what are the consequences of this? For example, many applications that are developed now for smartphones, for example, this one shown on the screen, which is a glucometer, something that people use to measure the amount of glucose in their blood. and they can send